Welcome to SME's AM Influencer Series, dedicated to the passionate professionals who volunteer with SME to connect the digital thread of additive manufacturing within traditional manufacturing. My name is Adam Penna, your host, leading customer engagement for our SME additive manufacturing community. I'm here with Dr. Brent Stucker. He's from Park City, Utah, and he is a distinguished engineer in additive manufacturing at Ansys, a premier company focused specifically on advancing simulation. And 3D Sim, the company Brent co-founded and led as CEO, it was acquired by Ansys back in November of 2017. He's also been a longtime professor and Fulbright scholar with a publication called Additive Manufacturing Technologies. And this book is the most widely read manufacturing book in the world. He's also a Dino Award winner, which is Distinguished Innovator in Operating Award from AMUG, the Additive Manufacturing User Group, in 2005. He has SMA affiliation going back from his past chair at the AM Technical Community Advisors, also an AM Coalition invite with a 2012 Industry Achievement Award. He started ASTM Additive Manufacturing International Standards Commission with SME, and he's also our 2021 conference speaker. Brent Stucker, welcome.
Thank you. Happy to be here.
Yeah, great to have you here. I've been excited leading up to this. Obviously, with your background, there's so many great things to talk about, and we all have a beginning somewhere, right, in this industry. So I was wondering what your first experience was with additive manufacturing.
Yeah, it's a great question. About 30 years ago, I was reading in ASME Manufacturing Engineering magazine when I was a student and first heard of this rapid prototyping stuff in the early 90s. And so when I set off to do my PhD, I thought, hey, this would be an interesting area to study for my PhD. So I started my PhD in 93, but the summer before 93, I got a small amount of money from my major professor to read every article that was ever written about rapid prototyping, which back then there wasn't very much because it was new, right? So went to the library, had to look up stuff old school. And then towards the end of that summer of 93, at the time I was living in the Northeast, I planned a road trip, and I literally drove to every facility in the Northeastern United States that I could find that had a rapid prototyping machine of any kind.
Cool.
And again, that was the terminology back then. We now call it additive manufacturing, of course. But so I visited facilities, like Ford and Chrysler. I visited little mom and pop shops that just happened to have some FDM machines, and asked them, like, if you were starting a PhD program, what would you study? And out of that summer and driving around and literally just meeting a lot of people who were sort of the original dinosaurs in additive manufacturing in a lot of these facilities, I got into this area and have dedicated my entire professional career of almost 30 years to additive manufacturing as a result. So that was kind of a fun thing where I got to meet early on, almost every single inventor of every single process, and saw, got to know people like Chuck Hull or, people who founded Stratasys, Scott Crump and others, because it was early on when there weren't very many people involved in research in this area.
Yeah, that's neat. That's a lot of great stuff going on back then, especially working with the guys that were starting everything up there. And I'm sure getting into rapid prototyping back then, that was like the beginning of the Wild Wild West, where everybody was kind of doing their own small practices and taking it to the limits in their own labs and getting to see all that, and it's pushing forward. And also the excitement around that new technology. I remember, in the 90s, looking at what was going on with rapid prototyping and thinking, wow, this is kind of what I dreamed of doing with my CAD background, and how I could take things to a different level and growing it layer by layer. It all of a sudden opened up a new world, so that was a very exciting time back then. And I guess, that kind of goes into where we are now. Now we're at things kind of pushing forward. There's been a couple of additive manufacturing growth. We just went through a different change with the pandemic. What you've accrued and the things you've seen, what advice would you have to people that are learning about or implementing or adopting AM?
Well, additive manufacturing really is broadened into a huge industry, of course. And so there's a lot to learn. And so if you're brand new, doing something like getting a book like the book, I wrote with David Rosen and Ian Gibson on additive manufacturing technology, that's super helpful just to sit down and understand what are these different processes that people call additive manufacturing. So also, there's a number of these different consulting firms out there that'll come in and do a training course or go to an SME course. And in particular, I think going to Rapid plus TCT is a perfect way to get your feet wet, because you can walk the show floor, you can see all these processes. And so those are sort of things that when people are new, I say, go, read a book, attend an intro workshop, go to Rapid, and if you own a machine, go to AMUG because you have to own a machine to go to AMUG. But yeah, those are some of the best ways to increase your learning quickly.
Yeah, it makes sense. There's a lot going on and there's a lot to grasp onto. And getting into that book, obviously the most read additive manufacturing book in the world, there's a lot of concepts in there that people can grab onto that it's in one place instead of having to dig that deep. And you've had the experience of digging that deep in many different places. So I'd like to cut to the chase and just get to something that actually goes over the whole range of what's been going on, because there's been a lot going on. There's a lot of different technologies, everything from plastic to metals has been developed and is developing further every day as we see new machines out there, new materials, new applications. It gets exciting. But yeah. I guess the impact of AM to the broad manufacturing industry as a whole, that's really where we're seeing the interest, of learning, because manufacturing obviously has its own processes, and additive fits in there in that digital thread. And so it's exciting to people. But what impact does AM to have to manufacturing as a whole?
Well, I think its impact is growing tremendously right now. If we think about, the first, say, 30 years of additive manufacturing, from say 1986 when Chuck Hull, started 3D Systems, all the way up to like 2016 or so, we were really rapid prototyping and maybe doing tooling for maybe it could be wax casting and things. But you were really using it for prototyping and making maybe molds and other things that were representative of what you wanted to build. But over the last, say, 5 years, we've seen this really the acceleration of real production of end-use components. Truly the additive manufacturing. We're manufacturing the goods using additive manufacturing. And so this is where I think we're really seeing the impact on manufacturing industry taking off right now. And really, it's only over the last couple of years. If you look at the Wohlers report, for instance, it's really recent that the number of parts made for in-use production has finally been greater than those used for prototyping and tooling. So we've really just gone over that inflection point here, maybe even during COVID. I mean, we don't know exactly. These are all kind of estimated numbers, but really somewhere within the last couple of years, we hit that inflection point where more parts made using these additive manufacturing technologies are actually used as the production part in an airplane, as an implant, in a toy. It doesn't matter. It could be just about anything. But rather than as a prototype to prove out a process, or as a tool that then is used as a jig or fixture or something like that. So I really think this is something that those of us who've been around for 20, 30 years have been looking forward to. And it's exciting that we're finally seeing that impact getting there.
Yeah, it is. It is exciting. And you're right on with the difference between looking at what used to be prototyped to now the end use parts. And it's actually the manufacturing methods that are being implemented for these end use production parts. So it's getting very interesting. It sure is. It's exciting to see that nowadays. And I can't imagine now what's coming up in the future. In general, I know you brought up SME with Rapid Plus TCT, and we do have that event coming up. How's your experience been with that SME event, Rapid Plus TCT?
The first time I attended that event, I think was, maybe back in 94, 95, something like that. And it's been a go-to event for me, for over 2 decades. The SME event is really the primary event in North America where you can see all of the various processes. If you're new, you can go to workshops and learn about, additive manufacturing and just kind of making sense of it. You can hear from practitioners about the latest and greatest that they've been able to achieve with additive manufacturing. So my experience with the SME event has been very positive. It's a nice size event. It's big enough to really see everything you want to see, but small enough that you're not overwhelmed by not knowing what to do and what to look at, because you can really see about everything you need to see on the show floor, as well as learn what you need to learn in the conference. So I really think it's a great event, and it's always one of the top ones I recommend people attend.
Yeah, it definitely is. It's been exciting for me over the years and to see both the technologies that are out on the floor and tour what's going on and have a hands-on approach and talking to the individual companies and then to sit in the conferences and hear the updates of what's going on. It really resets where you're at with the technology that's being adopted and understanding what could be done around there. So it's going to be exciting one this year, obviously coming back from the pandemic. There's a lot of good to look forward to and getting people together and actually enjoying what we've been doing in the industry. So looking forward to that in September. That's going to be in Chicago, September 13th through 15th. So I can't wait to be there and can't wait to do a lot of things there. So what are you most looking forward to this year at Rapid Plus TCT?
I'm looking forward to getting face to face. I don't know about you and other people, but I'm just tired of Zoom
Yep.
conferences,
Yep.
Teams conferences,
Yep.
whatever, WebEx conferences. I just want to get out there and shake somebody's hand, talk to them face to face, see parts. I mean, the thing about additive manufacturing is we're turning digital information into physical three-dimensional objects, right? Well, if all we're doing is looking at it on a screen, we're just still seeing the 2D. But
Yep.
getting to the trade show floor, seeing these things, and I love all the new announcements from the companies who do a lot of new product and technology announcements, seeing what's new, what's up and coming. But to be able to do that face to face is what I'm looking forward to after not having attended an in-person conference for a long time.
Yeah, it's going to be great. There's a lot to look forward to, and I know SME's been doing a lot with Rapid Plus TCT. There's a lot happening in the additive manufacturing space in general. But what role do you see SME playing in that additive manufacturing space?
SME is a unique organization in that it really has had both the longest running, but also I think the most impactful additive manufacturing community group in the world. Early on in the early era of rapid prototyping, they created this Rapid Prototyping Association, which helped bring speakers and companies into the Rapid event. And so it's been this really great synergistic relationship between SME and the additive manufacturing community now for well over 30 years, where it's SME with its overall manufacturing focus has given a great place for the additive manufacturing community to plug into that, right? And so I see SME as a great conduit for making connections between, maybe different users and companies, a place to find information. But in general, I think probably its biggest contribution remains this Rapid event because it brings thousands and thousands of people together every year to keep the industry moving forward. And not just in the United States, but also through partnerships elsewhere in the world as well.
Yeah, there's a lot going on globally that makes it such an amazing event, that's for sure. And I know you brought up the community in there. The AM community is something different. It's very 2% of the whole manufacturing world is additive manufacturing, not even just up to 2%. So as far as that group and our community, it's a very close community. People really help each other. People open up to what's going on and like to share information to help the industry grow. So what do you think defines that AM community? What would you say defines the community itself?
Yeah, within SME, the AM community is a special community. I've been involved with SME for a long time, and it's a very active community. It still feels young and vibrant, even though it's been going on for a few decades. There's a lot of young people involved in it, to be honest. We keep getting this fresh entry of new people who are just found out about additive manufacturing or 3D printing and are just excited. And it's a place where that excitement, they come together. You have a collection, and within the community, there's all kinds of different ways to get involved. You can sit on advisory boards, you can be on different technical committees, you can get involved in just about anything that's going to impact additive manufacturing through the community. And so I see that the SME AM community is really a great place for networking, and it's also been really influential just in the broader additive manufacturing community. Again, as you mentioned in your intro, it was the SME AM community that saw the need for international standards and then asked me to go out and help start this standards committee that turned into ASTM Internationals Committee, but also the ISO Committee on Additive Manufacturing Standards. Both of those came out of brainstorming within the SME AM community.
Yeah.
And so I see the SME AM community as really one of the most influential groups of people in manufacturing in general, certainly within additive manufacturing, but even within manufacturing in general. It's had a great impact on moving the technology forward and then broadening its impact, starting with this prototyping area and broadening it into manufacturing in general, aerospace, biomedical, et cetera.
Right.
The AM community has really pushed and driven a lot of that growth.
Yeah, it's exciting to watch that, and that's what's so vibrant about that community. There's always things growing, happening, opening communication lines and making different standards are big. You've been a big help with that, and you continue to be. That's huge. Everything we're just talking about standards. We need more applications so we can create more standards. It's starting to happen, so that is exciting. But you also brought up attracting younger generation to the additive manufacturing community. And so, what would be your advice be for attracting those people and keeping them into the new workforce for additive manufacturing?
Well, I think the educational community is really important here as well. And that's one of the things I've appreciated about the SME AM community is that it's engaged not only industry, but it's also engaged the professors and the students.
Right.
So, we're trying to get students involved in SME and in the AM community. And that's a great entry point into the industry, because I find if you can hook a young student or a young engineer get him in a course, and especially if you can get them to go to Rapid, they're hooked. That's what they want to do with their career. I've seen it over and over and over, and so I think that one of the things I encourage, young people is to, go to these conferences. Sometimes there's special rates for students at various conferences. Sometimes there's scholarships to go. Definitely go to Rapid and see and walk the show floor and get excited about it. But also, I really encourage people to take a course in it at their university as they're coming through, or even in trade schools. It doesn't have to be an engineering degree. There's a lot of courses and a lot of programs now out there in additive manufacturing. And so, just tell people, just get started on it. In fact, it goes all the way back into the high school and junior high areas. If you look at things like FIRST Robotics, and they are a huge user of, different little 3D printing machines and additive manufacturing machines to allow the students to build all these robots. And my son, for instance, was involved with this for years. And we, every day he would come home from school and we would print parts for his robot overnight, and he'd take him back to school the next day and put him on the robot and try it. And, seeing thousands and thousands of, students from around the world do this in things like FIRST Robotics really also, drives them into the area of additive manufacturing, because they have this ability to do design iterations as a high schooler, overnight. Let's try something, it breaks, come home the next day, CAD it up overnight, print it, next morning, take it to school. Not everybody has, a 3D printer at home. And my son was lucky enough to be able to bring one home from the school that owned it. And they let him put it in our basements. That way he could do that. He could iterate every night. But I think that not everybody has that, but a lot more and more schools, more and more universities, more and more trade programs are having that sort of hands-on availability. And I really think that is attracting the younger generation. Engineers are a small subset of the overall population, but within the engineering community, I think we're doing a pretty good job of making this area seem exciting.
It is, and you brought up a lot of things that feed into the additive manufacturing world. Of course, getting into the CAD side of it, the robotics side of it, that all drives what's happening inside of the print. So yeah, it's all a good grab for anybody to start off and looking at those things and then progress into the industry and some other stuff. So, and then you brought up, of course, being at Rapid. I love seeing the students at Rapid plus TCT every year. As a matter of fact, I've been, I want to say not guilty, but I've been happy to just spontaneously tour students around the floor because I just enjoy it. Hey, let's go take a walk around, grab groups and start showing them each of the individual technologies. And it's always a great time. You see those, the young minds getting excited, seeing new things. And you're right. That's what kind of grabs everyone and brings them in and makes it more of a, hey, this is something I could really, really stick to and go with. So,
yeah. And I think one of the things I've appreciated about, the Rapid event is that, often people at other events kind of ignore these young people who walk around because they know that they're not going to be the ones that they can sell to, right? But at Rapid, when I've had booths and been in booths, we take time and we volunteer to say, hey, bring the students here. We'll tell them what we do. Let's educate them. Let's get them excited, whether it's simulation, whether it's, whatever. they need to understand, what's new and exciting in this area. And so I really do like that, how at Rapid we bring all kinds of young people in there and let them tour around. It's it is from an immediate return on investment. You're not going to sell to them, right? They're not there to
Sure.
shop, but we are. It's a long-term investment in the health of our community, and I love that SME does that kind of investment.
Yeah, it's very important, big time. That next generation is exciting. I learn a lot from the next generation. So yeah, it's give and take. It's both sides are getting something out of it. They might not be buying a machine right away, but they are influencing what goes on in the universities, the purchases that go on in the universities, and also investing in the future, getting to see things early that becomes normal to them. That's what they look for when they're out in the workplace. So yeah, it's a great investment on both sides, and I'm always happy to be part of that, because it's exciting to see those young fresh faces take a hold of what's going on. And yeah, looking forward to that this year, because I'm sure there'll be a lot of that also. Yeah, exciting stuff. And I know AM has evolved. We talked about it, a lot evolving over the years. Now going forward, what do you see like evolving in the next few years for additive manufacturing?
I really think that we are to the point where we're really shifting from an emerging manufacturing technology into a established manufacturing technology set. I think the maturation of machine types, and understanding how these different types of additive manufacturing processes work, they're becoming quite mature. The machines are becoming more robust. And the relatively new influence of simulation, where you can take a design, you can simulate it and understand how is that part going to work in this process, and we can predict how the shape changes are going to be and all these things about it, even the microstructure and the properties of the part. So all of these sort of tools that we've applied and expected out of traditional manufacturing are now being applied to additive manufacturing. And so I really think over the next few years, it's really going to become just widely accepted that additive manufacturing is just as good as machining or forging or investment casting as an option. It's no longer going to be, well, you have to have some sort of special approval process to get this new and emerging technology approved to build this critical component. It's not going to be like that. It's going to be, it's just another manufacturing process. And I think that that's going to really help the financials. It's going to help all these companies be on a much better, stronger financial base, because we don't keep having to prove ourselves over and over and over and go through these long, tryout and approval and educational periods. But I also think there's some really cool technologies coming down the pike. There's things people are doing to change and tweak the machines to make them faster, more robust, work with more types of materials, and even some new ways of joining materials and new types of materials that are being joined to do additive manufacturing. It's still a very dynamic industry. So I don't really see that this, maturation makes us now boring. It's actually, it's going to help the whole business side be a lot more stable. But at the same time, there's plenty of other amazing things on the research side we can do to make the technologies even better. So I really, even today, I have, having been a professor, I have a lot of, young people come up to me and like, is this a really good industry to get into? Is this something? I'm like, yes, there's so much left to do that don't worry about your career. Even if you're in your teens right now or 20s, you have an entire career ahead of you of amazing things we can do in additive manufacturing. It's not a dead end career. It's not a dead end community. It's a truly evolving, emerging, exciting place to be in a career in this area.
Yeah, it is. That's a lot of great points there. And I know you brought up simulation, especially being with ANSYS. I have a couple questions for you as far as, simulation itself has been and continues to develop. And for additive manufacturing specifically, I know there's things like build simulation, material simulation, flow simulation, all these things that pertain to additive. Can you talk about a few of those that are the simulations that are current and being developed for additive that we should know about?
Sure. I'd say some of the what I almost consider bread and butter type simulations now that our customers are doing is you have some sort of shape. You're trying to decide what orientation to put it in the machine and where do I support it to get success. And so we have software that helps you choose the right orientation and where to put supports. And then you can run a process simulation that says, now in this orientation with these supports, what's going to happen to this part while the process is running? And we can predict how it deforms and twists due to just the heat and the heating and cooling that occurs in these layering processes. So what you're going to get then is some sort of predicted distortion. So the part is designed in a certain way, but every single additive manufacturing process, as you build that geometry, it kind of bends, it twists, it curls a little bit. And the nice thing about simulation is we can predict all that bending, twisting, and curling, and then compensate for that. So really, one of the best things that people use it for today is you give it a geometry, will tell you how it bends and twists and distorts, and then we can reverse that in your geometry such that it twists to the correct shape. So now you can build much, much more accurate shapes, and we call that distortion compensation. And there's thousands of people doing that every day now who, I got a shape, I want it to be as accurate as I want, I'm just going to run a distortion compensation analysis and give me the shape that when I put it in my printer, it's going to turn into the right shape for me. And that's a great tool, because it used to be you'd have to run a bunch of iterations,
Right.
build it, tweak the design, build it again, tweak the design, maybe change the orientation a little bit, build it again.
Yeah, time and money, time and money, time and money over and over again. Yeah, that's why it's
Exactly.
so important. And ANSYS does such a great job with it. It's great to see the new tools that are coming out that are needed in additive, because there's so many different ways of approaching a build, and like you said, the different technologies. And if you could simulate the different technologies to see what happens, you could see what the best way of building something might be. Wow, that's where people start to really speed up the process, and things become a lot quicker. And that price of that last, the unit itself is less, because you're not wasting a lot of material, a lot of iterations to get where you need to go. And that's exciting. That's exciting. And it's amazing that software could do that. That's software to me is the future in a lot of ways. The machines are at a certain point, and the software almost has to catch up to control things, to make sure what we're doing isn't wasted, and we don't have to go through too many iterations, and we're able to find the right solution, maybe also to pick the right technology. It might not be additive that works for you, but you could find out through your simulations if you're heading the right way or not. That's very important in the manufacturing world. So always interesting to see the new things coming out with simulation. So great to hear that stuff. Now, it's been great talking to you, Brent. Is there anything else you'd like to add while we have you here?
One other, down the same thread of simulation, I think one of the other things that is really exciting to me is how simulation is starting to be used to redesign the process itself. Like, what size of laser should I really have to get the best productivity? What should be the diameter of this laser, or how much heat should I put there? Those are sort of things that, as a professor, I used to have take an entire PhD program, and I have a student working on it for 4 years or 5 years, right? And they would make one conclusion out of that. And and look back at my career in the, I don't know, 40, 50, 60 students, I don't know, somewhere in that range that I advised, and see how long it took back in the past to really move the bar on a new material or improving the process. And today, we're moving that bar quicker and quicker with less and less work, primarily due to simulation. And for me, it's really exciting. Our industry has grown relatively fast. If you look at just about by any metric, we have really good compounding growth. But I think that growth can actually accelerate. It can even go higher with simulation. And so for me, that's really the reason I left academia and pursued a simulation company, is because I think it's really, as you said, the software that was behind. The machines were more capable of doing things than we were able to make the machines do. And until the software caught up, we couldn't actually take full advantage of the cool things that additive manufacturing machines could do. Now we're starting to say, well, software is starting to catch up with the ability of the machine. Now we're going to have to both improve the software and the machines to keep growing faster. But the nice thing is they're synergistic.
Yeah.
The software helps the machines go better. The machines are designed based upon the software. So the it's really a synergistic relationship. And so I'm excited about the next decade, and just really seeing this new kind of simulation driven additive manufacturing and how it's going to impact the industry. And for me, that's it's exciting to see it. It's exciting to be a part of.
Yeah, it's a huge impact, and everything you're doing has obviously been that. So it's very exciting to talk to you today. Hey, thanks for being here, Brent Stucker. I really appreciate you doing this, and thanks for being a positive leader and an SME additive manufacturing influencer.
My pleasure. Thanks for having me.